Okay, so this video I'm going to show you all how to do a two-sided hypothesis test. So this is kind of material from 8.2 and 8.3. I just want to run through. We did one in class that was a one-sided test, and so two-sided tests are the ones that have a not equal sign. So remember that there are sort of three HA options, right? And for means, that would be mean less than some number, mean greater than some number, or mean not equal to some number. And we did one like this in class. This one would be similar, right? But you'd just be looking at the opposite kind of end of the table. So you'd be kind of doing 1 minus, and I'll do an example of that one in another video, but you're just looking for the opposite, right? This table gives you less than probabilities. This would be looking for the probability that your z was greater than whatever statistic you get. So you just have to do the 1 minus for that guy. But this one requires a little bit of extra work, and so I wanted to show you all a little bit how that works. And so I took number 9 out of the book, and I think it's number 9 from section, section 8.3 it looks like. So it's number 9. And when I assign these problems, if you'll see on Moodle, I don't really care that you do the steps that are in here. That's kind of annoying to me. So really, what I want you to do in every single problem that's assigned in these sections is just perform the hypothesis test. Ignore all these parts A, B, and C. Just do the 6-step process that we talked about. Okay, so this number 9 says that the mean score on a 25-point placement exam in mathematics used for the past 2 years at a large state university is 14.3. The placement coordinator wishes to test whether the mean score on a revised version of the exam differs from 14.3. She gives the revised exam to 30 entering freshmen early in the summer. The mean score is 14.6 with a standard deviation of 2.4. And they want us to perform a test at the 10% level of significance. Okay, so this is talking about in our first step, so step 1, right, is to write down our hypotheses. And here it's wanting us to test the alternative hypothesis is that the mean score on a revised version of the exam differs from 14.3. So that the mean differs from 14.3. So when you see that word differs, right, that's when you're going to use this not equal sign for that portion of the hypothesis test. And then up here in the H naught, that is going to be the mean equals 14.3, right, because that's what was assumed from if this test doesn't actually differ from the revised exam, it would be still equal to the old one of 14.3. So that's step 1, is to get our hypotheses. Step 2, we do have n is greater than or equal to 30. We have exactly 30, so that gives us the condition to tell us that we can use a z-test. So that's good. That's the sort of checking of the conditions and deciding what test we're going to use. Step 3 is to calculate the test statistics. So remember, you're going to calculate a z. And your z here is 14.6. If you recall the sample, so they collected sample and they got 14.6. That was the x bar from the sample. And 14.3, right, is the mean from the problem. You divide by the standard deviation that was given the problem. The standard deviation was 2.4. And then you divide that by the square root of n, and in this case, n is 30. So you calculate all that out, and you get a 0.68. So as a note, this 14.6, right, that is your x bar. So 14.6 was x bar, right, and 2.4 was s, and n was equal to 30. And those are all numbers that were in the problem when I read it. I don't know if you noticed, or if you can go back and look. So that was all stuff that was given to you in the problem. Okay, so we now know we have a z of 0.68, and so the next step is to kind of decide on what our p-value is and or kind of draw that rejection region. And I'm going to kind of draw the picture because I think it really helps kind of understand how to do these problems that involve a two-sided test. Okay, so the first thing I want to do is write back up here what our z-score is, right? So our z was 0.68, so that's going to be important. So as we perform step 4, what we're going to look at, right, is in the problem, I guess the first thing we need to know is that alpha, which is your significance level, is 0.1, right? So that's the significance level that's mentioned in the problem, 10%. Okay, so that was decided before we even started the problem. So alpha was equal to 0.1. So now though, right, if we do a less than, we look at just less than in the picture. If we do a greater than, we look at just greater. And if it's a not equals, we kind of split the difference, right? So here's your 0, right? And now I want my total sort of rejection to be 0.1. So that means on this side, I have some, and on this side, I have some. But I want that total area to equal 0.1. So you just kind of divide it in half. So this would be like 0.05 on this side, and this would be 0.0 on this. Okay, so now we need to figure out how we're going to calculate our p-value. And we had 0.05 on that side and 0.05 on this side because we have to split the difference, because as a not equals, we don't really know if it's less than or greater than, so we test it on sort of both sides. So now we're going to calculate the p-value, and the p-value here is calculated a little differently. So it's 2 times the probability that z is greater than 0.68. That's how we'll calculate it for our example. Because we have to account for the fact that we want a little bit on each side, so we just multiply it by 2 to calculate sort of what the probability would be sort of on this side plus the probability of what it would be on this side. So we're sort of splitting that difference, and that's how we're getting 2 times. So it's sort of the 2 things on both sides. If your z was a negative, so if you had a z was negative, just remember that instead of greater than, you would use 2 times the probability that z is less than whatever that number is. Because in that sense, right, you would want to make sure that you got the negative side right to the right of 0 and multiplied that by 2. So just whatever your sign is, if it's positive, do greater, if it's negative, do less than, and then you'll be set. So for us, right, we're going to calculate the p-value being greater than 0.68. Okay, so we're going to go to our table, and we're going to look up 0.6 on this side and 0.08 up here, because, right, that's the z-score, right, not a probability, and we want to find the number that's located right here in our table. And if we do that, we'll get, looking at my table, 0.7517 is the value that you get from that table. So now you're going to take that and you're going to put that here, but be careful, right? This is the probability that z is less than 0.68, because the table shows us less than values, not greater than values. So what we need to do is convert that to the probability that z is greater than 0.68. We do 1 minus. So 1 minus 0.7517. So we get a less than value of 0.2483. So that's the less than part. And so that's the part that we'll use in our formula. We'll take this, right, and plug it in here to get our p-value. So we don't even have our p-value yet because you have to do that 2 times stuff. So to do the 2 times stuff, we're going to take our p. P-value, remember, is 2 times the probability that z is greater than 0.68. And we now have that probability, so it's 2 times 0.2483. So we get a p-value of 0.4966. Okay. So now it's time to do step 5, and step 5 is to check this, right? The p-value is 0.4966, and that is certainly greater than 0.10, which is our alpha. So since it's greater than alpha, then that says we fail to reject H naught. So we have that done. And now it's just time to write our conclusion sentence, right? So there is not significant statistical evidence to conclude that the revised exam differs from the original in terms of mean score. So that is the process for doing a two-sided hypothesis test with that not equal sign in there. Hopefully that helps with those kinds of problems. I'm going to do one more in a separate video using a t-distribution just so you can see one example of that.